Hello. Today we are going to be solving equations with x squareds in them, meaning that we will have to take the square root. Please feel free to watch this video as many times as you like and make sure you write down the notes and pause it if you need to. So today we're going to be talking about solving an equation like this example right here where it says x squared equals 25. So the logical thing to do when you have an x squared to get just x by itself is to take the square root, because that undoes the squared. What I would like to encourage you to do first is think about what numbers are possible for x in this equation. And the possible values of x are obviously 5, because 5 squared is equal to 25. Now, the creative part about this is that another number that works to plug in for x is negative 5. Because negative 5 squared, well, if you think about this, that's negative 5 times negative 5. It's negative 5 times itself 2 times. When you multiply two negative numbers, you get a positive number, so the answer to this is 25. So, there are actually two values for x that work in this equation. X is equal to 5, and x is equal to negative 5. And when we solve these equations, you're going to need to account for both possible values of x, because when you take the square root, you have to understand that the original number was squared, so the original number could have been 5 or negative 5. Now let's go on to this example. In this example here, we don't have just the x squared by itself. So our goal here is to isolate the x squared, so we get the x squared by itself, and then at the end we can take the square root. So this we solve just like a regular equation. The first step would be to add 108 to both sides of the equal sign. Negative 108 plus positive 108, those equal 0. Essentially, because they equal 0, they cancel out, just like we did at the very beginning of Algebra I. So the next line of our equation is 3x squared equals 108. Then our next step is to take the 3 and divide by 3, because those will, 3 over 3 is 1. Essentially, you don't have to write the 1 in front of the x squared, so they cancel out. Divide this by 3, you get x squared equals, and then 108 divided by 3 is 36. Now, because our x squared is by itself now, it looks a lot like this equation, x squared equals 25, but this one's 36. So we can take the square root of both sides to figure out what numbers work for x, because it doesn't have to be just guess and check. So in this case, the square root of 36 is 6, so my x value is equal to 6. The issue is that we need to be smart enough to know that, like in this example, two values work for x, both 6 and negative 6. Both values work for x. A lot of times you will see that written as x equals plus or minus 6. Our mathematicians like to condense things. So that's how we solve these equations for x. Now we're going to talk about what this does for you graphically. So graphically, remember when we graph something that has an x squared in it, it's going to be a quadratic, so that means it's a parabola. And when we're talking about a parabola, it has something called x-intercepts. Now the x-intercepts are the places on the graph where your parabola touches the x-axis. And there are a couple of different possibilities when to find out what happens when the graph touches the x-axis. So the first possibility is that you've got a parabola either opening up or opening down, but in either case, the parabola touches the x-axis in two spots. Here's one x-intercept, and here's the other. So both of these are considered x-intercepts. And we would list these as points, whatever the x value was for both of these. The nice thing is, both places on the x-intercepts, the y, will be equal to 0. Okay, so we would list this point, maybe this one is at 2, 0, and maybe this one is at negative 3, comma 0. I'm just giving you some for instances. But that we would list these as the x-intercepts, -3, 0, and 2, 0. Another scenario is that there's only one x-intercept. And in that case, the parabola is sitting right on top of, or right underneath, the x-axis. So it kind of just only has one x-intercept. This one is two x-intercepts. This one only has one x-intercept. And so in this case, you would list only the one x-intercept. Let's call it 1, 0. And again, in all of these x-intercepts, the y is equal to 0. Finally, the last scenario of x-intercepts is, well, if we've got 2, we've got 1, there is a possibility that this parabola will never touch the x-axis. Either it's too far above or too far below the x-axis to even touch it ever. So in this case, there is no x-intercepts. There are none of them. In this case, we would find that there is no solution if we were going to solve. To find these x-intercepts. And that's kind of what we're going to be doing today, deciding where the 2, 1, or no x-intercepts exist. So let's look at an example of trying to find the x-intercepts. The learning targets are 8 and 9, and we're going to try and find the x-intercepts in this quadratic function y equals x squared, or y equals 4x squared. So remember when we have the x-intercepts, what is the y value that I said always exists when we're finding x-intercepts? That's right, it's 0. So the y value is always 0. The y is always 0 at the x-intercepts. So what that gives us the ability to do, since we notice that pattern, is that we can plug in 0 for y. So in this equation, instead of a y, I can plug in 0 equals 4x squared. And now what we're going to do next is solve this equation just like we did on the first slide. The first step would be to isolate the x squared by dividing by 4. On both sides, 4 over 4 cancels out because it's 1. 0 divided by 4 is 0 equals x squared. Now, we go ahead and get the x by itself. Without the squared, we take the square root. Now, the square root of 0 is 0, and in any other case, we would say, well, it's positive and negative because we account for both scenarios. But that doesn't exist at 0. You can't have a positive 0 and a negative 0. So we would say that this is just x equals 0, and there's only one x-intercept. Okay? So there's only one x-intercept in this case. It's only at 0. Now, you can double check this by putting in your graphing calculator y equals 4x squared. Because this a is 4, that means it's going to be a narrow graph. The graph looks something like this. And you can see that it's touching the x-axis right there at x equals 0. Let's do one more example. Let's find the x-intercepts of this equation. Y equals 2x squared plus 32. So our first step, again, is always the same. If we're finding the x-intercepts, you let y equal 0 because we're trying to find where they touch the x-axis. So 0 for y equals 2x squared plus 32. The next step is to try and get the x squared by itself, so we solve this like a regular equation. First step is to subtract 32, subtract 32. And we get negative 32. 0 minus 32 is negative 32 equals 2x squared, and positive 32 minus 32, those cancel out. My next step is to divide by 2. So I get x squared equals negative 16. And then what's our last step finally? to take the square root, that's right. So we take the square root of both sides. And x equals, now if you were to plug in the square root of negative 16, you're going to get something like this. You're either going to get an error, or your answer will have an I in it. And the trouble is, we don't have numbers with I's in it yet in Algebra 1. And if it's an error, that's a problem. So when we have the error or the I situation, that means that there are no x-intercepts. There's no solution. And in this case, we would see that, well, our A value is positive, so it's opening up. And since there's no solution, it's basically a parabola that is so far above the x-axis that it's never going to touch the x-axis. So there are no solutions here. No x-intercepts. Good luck trying to find your x-intercepts, and please feel free to watch the video again. Thank you.